Welcome, ladies and gentlemen, to Math with Kieno. And today's video is brought to us by a special request from a friend of mine in Houston, Texas. Sugarland, Texas, to be exact. She's having problems understanding systems of equations, and I am here to figure it out for her. Or help her understand it, not figure it out for her. So, systems of equations. All right. Systems of equations. All right. We are primarily going to deal with four methods, but what's the point? What's the point of the systems of equation thing? Well, we'll have two linear equations. Y equals mx plus b in that form, or it could be in another form, and then we have to change it into y equals mx plus b. And then on a graph, which is the first method, graphing, on a graph, our two linear equations are going to do two things. Either they're going to cross at some point, either they're going to be parallel to each other and never cross, or they'll have the same x and y intercept, which indicates that they're the same line. So this has no solution. If we're solving to see where these two lines intersect, there's not going to be a solution. If they do, we're going to have an x and a y value, a coordinate, where we 1, 2, 3, 4, 5 on the x-axis and 1, 2, 3, 4 on the 5. So 5, 4. We'll find a point on the graph where the two lines intersect. Or they won't intersect anywhere because they'll have the same x and y axis and they'll be the same identical line. Alright, so that's the whole point of this systems of equations stuff. We're trying to find out what two linear equations are doing, or even if they are the same equation, or if they'll never cross at all. So, that being said, there are four methods we use. We're either going to get graph paper out and we're going to graph, which is the graphing method, ing. We will substitute, we'll use substitution. I'll just put sub for short, or substitute for short, substitution. Or we'll use a process of elimination. And we will add or subtract to get it. So graphing, substitution, and this is actually two methods in one, because we're going to add or subtract to eliminate. Okay, so basically, that's primarily what the methods that we're going to use. So we'll talk about the first one, which is the graphing method. Alright. Let's just say, and I have dots here that you probably can't see, but I'm going to make a y-axis, and I'm going to make a x-axis. Okay, and I'm going to make my points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and these are just your x and y axes, are just number lines. And when we're talking about an axis plural, we call them axes, not axes. Axes. Okay, what do you guys think about that? Pretty decent, huh? Okay, so moving right along. The graphing method. In order to use the graphing method, the linear equations are going to have to be in what we call slope-intercept form, which is y equals mx plus b. Now, why do we want it in the simple format? Because when we simplify it like this, we're going to get the slope-intercept form. We're going to have a slope, so we'll know what the line is doing, whether it's going up or coming down, positive slope or negative slope, and then we'll know exactly where it crosses on the y-axis. Okay, so that's the point. That's the whole point of breaking it down. But the thing is here, you're going to be given two equations. So, let's see what we got as far as real estate. Center this thing a little bit. And, okay, looking halfway decent there. Okay, now, so, we have two equations in the system of equation, and it's going to be y equals negative 3x plus 2, right? And then our second equation is going to be y equals negative, no, it's 2x minus 3. 2x minus 3. All right, now just by looking at those two equations, I could see two things right now at this point. If you understand the slope-intercept formula, this is equation A, and we'll call this equation B. All right, equation A, this is telling me negative 3, which means we're going to have a negative slope, and it's going to fall 1, 2, 3 points, and then run 1. 1, 2, 3 points, run 1. 1, 2, 3 points, run 1. That's how we're going to find point after point after point. And B, we have a positive because the 2 is positive. This is the slope. It's 2 over 1. Even though we have whole numbers, they're fractions in a sense. So the A would be negative 3 over 1, and B would be 2 over 1. So with the negative, we fall 3 points, run 1 point. Here we rise, because it's positive, 2 points and run 1 point. So to find our point, let's say if we had a point here, in this case, we rise 1, 2, and over, that's our next point. Rise 1, 2 over 1, that's our next point. Rise 1, 2 over 1, that's our next point. And then we line them all up. Okay. So I know what the slopes are going to look like if they gave you like a multiple choice and put a bunch of graphs up. The second thing I know about these two equations is that the y-intercepts. I know that equation A is going to intercept the y-axis at positive 2. I know equation B is going to intercept the y-axis at negative 3. Negative 1, negative 2, negative 3. That's another thing I know. Now, based on me knowing the slopes, I could work this out, or I can make a table. Okay, so here's how, if you just wanted to say, you know what, I don't want to make a table. I know the slope. Equation A falls 3, runs 1, falls 3, runs 1. So I could go like this. 1, 2, 3, run 1. That's my second point. And then I could be like, you know what, I'll make a line. Okay. Then I could look at this and I say, this rises 2, runs 1. So I could rise 2, run 1, and ooh, look. At 1, negative 1, we found the solution to our system of equation. These lines intersect at positive 1, negative 1. Now, another thing you could have did was you could have just came up with other points by inserting 0. Let's say we made a table for this equation and we say, okay, we're not going to do the rise run method. We're just going to plug in, make a table, and we're going to plug in, we already know, in this case, negative 3, because we're equation B. We know negative 3 is going to be the y-intercept. So we need to find some more points. Let's say positive 4. And we want to find another point. So we'll plug in positive 4 here. 2 times 4 is 8 minus 3. The y value is going to be 8 minus 3 is 5. Alright. So the y value is going to be 5. So we come over 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay, and then we just make a line. So we plug in values, but we already knew it a while ago. So that's how we deal with that. Okay. Another thing that needs to happen is we need to test our value. We need to test. All right, so this is our solution. 1, negative 1. So when we put 1 in x, we get negative 1 for the y value in both of these systems. So negative 3, we plug it in 1, plus 2. In this equation, down here, number 2, 2x, 2 times 1 minus 3. So they both need to equal negative 1 in order for this solution to be true. So negative 3 plus 2 is negative 1, and 2 minus 2 times 1 is 2, minus 3 is negative 1. So it worked in both of the equations, and that's how you tell whether your solution that you came up with is true. So your solution says both of these lines intersect at x value 1, y value negative 1, and we can plug x and y in both of these equations and they both work. Alright, let's do another one. Okay, brand new graph. All right, let's say our new equations that we're going to work with are y equals 1/2 x minus 3. This is in y equals mx plus b form. And then we have 3x plus 2y equals 2. That is not in y equals mx plus b form. So we have to look at that and we need to see what do we need to do to get it in y equals mx plus b form. Alright, what we need to do is we need to subtract 3x from both sides, theoretically, but what's actually happening is the 3 moves to the other side of the equal sign and changes signs. So to change this, we would have 2y equals negative 3x plus 2. Alright, but then we can't leave it there like that. So I'm just going to write the line up here because we ran out of real estate on the bottom. So in order to turn this into y equals mx plus b form, I'm going to divide everything by 2, and it will be, these cancel out. Y equals negative 3x over 2 plus 1. Alright, 2 divided by 2 is 1, and so this is our y equals mx plus b format. Alright, now this equation and this equation are the same line. Same line. but this is the slope-intercept form. Now, what can I tell so far? I can tell that this is a negative slope, which means it's going to go in this direction, downward. I can tell that this is a positive slope, 1/2, positive 1/2 x, rise 1, run 2. So it's going to go like that. It's rising. The second thing I can tell about equations A and B is, let's see, the Y-intercepts. A is going to penetrate across the y-axis at -3. B is going to cross the y-axis at 2. Okay. Now, to simplify it, which I won't simplify it. I'll just leave it. I'll leave it as is. But we know that this is basically this system. So I'm just going to take this out because we're going to do some math. For equation A, when I'm making a table to find out my points, I know that -3 is the y-intercept. So if x is 0, the y-intercept, the y point is -3. Let's say 2. Yeah, 2. So 1/2 times 2 minus 3. What is that going to equal? Alright, well, 2/1, 2 times 1/2 times 2/1. 1 times 1 is 1. 4, 2, 5/2, which is 2.5. So if we plug in 2, we're going to get 2 1/2. And then let's add another point. If we get 1, we plug in 1, 1/2 minus 3, and I'm sorry, the 1 yields 2.5. The 2 double 1 is 2. Sorry about that. So you got to always be checking your math. You can either do that. Another thing to test it, it's rise over run. 1, 1, 2. 1, 1, 2. Alright. And for the other one, we said is negative is going to fall 3, run 2. So you get 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. Our numbers our dots are a little bit off. That's why the best way to do this is with graph paper. Okay, so we actually wind up crossing at 2, -2. Now again, you can plug the 2 in the X spot. The result should be -2 when you work it out. So Y should be -2 when we plug 2 in. So 3, -3 times 2 plus 1, 6/2, which equals -3 plus 1 is -2. Alright, so we just tested it, and that works. Trying to find because when you do it like that, it's kind of like almost like guesswork almost. So what I'm going to do is I'm going to get a piece of graph paper. I'm going to grab some tape, and we're going to work out a graph the old-fashioned way. Okay. All right. Now, our system, equation A, negative 1 over 2x plus 4, B is negative 1/2 x minus 6. Now, there's a couple things I should know at this point. And I forgot to put y equals where the a's are. Should be y equals where the b is. Y equals negative 1/2 x minus 6. The slopes are the same. The slopes are both going like this. They're negative, so they fall over run. They'll fall one point, run 2, 1, 2. Fall 1, run 2. Fall 1, run 2. The second thing we know is that at positive 4, negative 6, those are Y-intercepts. Equation A, 1, 2, 3, 4. Equation B, 1, 2, 3, 4, 5, negative 6. This is the origin. Alright, so that's what I know. And really, at this point, if I want to find a line, the slopes are right there. We're fall 1, run 2. Fall 1, run 2. Same here. Fall 1, run 2. Fall 1, run 2. Negative slope. Now, if I take these lines, connect the dot with a line, and this line is y equals negative 1/2 x plus 4. This line y equals negative 1/2 x minus 6. This is no solution. There's no solution because these lines will never intersect each other. That's the whole point, to find out what these lines are going to do. I wish I had a so hope that worked, and I hope that's close enough where you can see. So that's the graphing method. And we'll stop right there in the interest of time.